Light, it's everywhere. It brightens our days, filling our world with color and warmth. From the moment the sun rises, casting its golden glow over the city, to the last rays of sunset, light is an integral part of our lives. It lets us see the world in all its beauty and complexity. It illuminates the landscapes we cherish and brings out the details in everything we observe. But what is light, and how does it get to us? This question has fascinated scientists for centuries, leading to countless discoveries and innovations. Light is a form of energy that travels in waves. These waves can vary in length, giving us the spectrum of colors we see. These waves are made up of tiny particles called photons. Photons are the fundamental particles of light, each carrying a specific amount of energy. Think of photons like little packets of energy, constantly on the move. They travel at an incredible speed, reaching us almost instantaneously. Light's journey is an amazing one. It can travel vast distances, crossing the emptiness of space to bring us the light from distant stars and galaxies. It travels from the sun across the vastness of space and reaches us here on Earth. That's a long way. The light we see from the sun takes about 8 minutes to reach us, traveling at the speed of light. Understanding light helps us understand our universe. By studying light, astronomers can learn about the composition, temperature, and movement of celestial objects. It's the key to everything from rainbows to telescopes. Rainbows are created when light is refracted or bent by water droplets in the atmosphere, splitting it into its component colors. So, let's shine a light on this fascinating subject. By exploring the nature of light, we can uncover the secrets of the universe and appreciate the beauty of the world around us even more. Imagine shining a flashlight in a dark room. What do you see? You see a beam of light traveling in a straight line. Light naturally wants to travel in a straight line. This is called rectilinear propagation. It's why shadows have such sharp edges. Think about it. When an object blocks light, it creates a shadow behind it. The shadow's shape matches the object perfectly because light travels in straight lines. Of course, light can be bent and scattered, but its natural tendency is to travel straight ahead. It's a fundamental rule of the universe. Light may love to travel straight, but it encounters many obstacles on its journey. When light hits an object, it can be reflected, refracted, or diffracted. Reflection is like bouncing a ball. Light hits a surface and bounces off in another direction. Think of mirrors. Refraction is like bending a straw in water. Light bends when it passes from one medium to another, like from air to water. Diffraction is like waves spreading out. Light spreads out when it passes through narrow openings or around obstacles. These interactions are what make light so fascinating. They're responsible for everything from rainbows to the colors we see. Hold on to your hats because light travels incredibly fast. In fact, it's the fastest thing in the universe. We call this speed the speed of light, and it's about 299,792,458 meters per second. That's approximately 186,282 miles per second. To put that in perspective, light could circle the Earth over 7 times in just 1 second. It's mind-bogglingly fast. This incredible speed has huge implications for how we understand the universe. For example, it's why we see stars as they were in the past. Section 5. Light in our lives, from vision to technology. Light is essential for our daily lives. It is the very essence that illuminates our world, making everything visible and vibrant. We need it to see. From the moment we wake up and draw the curtains to let the sunlight flood in, to the times we switch on a lamp to chase away the darkness, light is our constant companion. Our eyes detect light, allowing us to perceive the world around us. The intricate design of the human eye captures light and translates it into images, enabling us to navigate and appreciate our surroundings. But light does so much more than just help us see. It interacts with the world in fascinating ways, like creating beautiful patterns when it passes through a prism or casting enchanting shadows through leaves. It's used in countless technologies that shape our modern world. From the lasers in scientific research to the LEDs in our screens, light is at the heart of many innovations. Think about fiber optic cables. These slender strands of glass or plastic use light to transmit data over long distances with minimal loss. They use light to transmit information at incredible speeds, enabling us to connect with people and information globally. Or consider solar panels. These marvels of technology capture sunlight and convert it into electricity, providing us with a clean and renewable energy source. They harness the energy of sunlight and convert it into electricity, providing us with a clean and renewable energy source. Solar panels are a testament to how we can utilize light to power our homes, cities, and even industries sustainably. These are just a few examples of how light impacts our lives. From the screens we use daily to the streetlights that guide us at night, light is intricately woven into the fabric of our existence. It's a fundamental part of our existence and plays a vital role in shaping our world. As we continue to innovate and explore, the potential uses of light are boundless, promising a future where light continues to illuminate, connect, and empower us in ways we have yet to imagine. Section 6. Reflection, bouncing off the surface. Let's dive a little deeper into reflection. Remember, reflection is when light bounces off a surface. When you look in a mirror, you're seeing your reflection. Light from your face bounces off the mirror and into your eyes. The angle at which light hits a surface is called the angle of incidence. The angle at which it bounces off is called the angle of reflection. The law of reflection states that the angle of incidence is always equal to the angle of reflection. It's a simple but powerful rule. Section 7. Refraction, bending the light fantastic. Now let's talk about refraction. Refraction occurs when light passes from one medium to another, like from air to water. When light enters a denser medium, it slows down and bends towards the normal. The normal is an imaginary line perpendicular to the surface. Think about a straw in a glass of water. The straw appears bent at the waterline because light from the straw is refracting as it passes from water to air. Refraction is what makes lenses work. Lenses are curved pieces of glass or plastic that use refraction to bend light and form images. Section 8. Diffraction, spreading the light waves. Last but not least, we have diffraction. Diffraction is the spreading out of light waves when they pass through narrow openings or around obstacles. Imagine shining light through a small slit. Instead of seeing a sharp line of light, you'll see a pattern of light and dark bands. This pattern is created by the diffraction of light waves. The waves spread out after passing through the slit and interfere with each other. Diffraction is why we can hear someone talking around a corner even if we can't see them. Sound waves, which are also waves, diffract around the corner. Section 9. The speed limit of the universe, light's constant. We've already established that light travels incredibly fast. But here's the thing, the speed of light is constant. This means that no matter how fast an object is moving, the speed of light relative to that object will always be the same. This concept is one of the foundations of Einstein's theory of special relativity. It has profound implications for our understanding of space and time. For example, time actually slows down for objects moving at speeds close to the speed of light. It's one of the strange and wonderful consequences of light's constant speed. Section 10. Seeing the light, its significance in our world. Light is more than just a fascinating scientific phenomenon. It is a fundamental aspect of our existence, influencing everything from the smallest microorganisms to the largest ecosystems. It's essential for life itself. Without light, plants wouldn't be able to perform photosynthesis, a process that not only sustains them but also provides oxygen and food for countless other organisms. Plants use light for photosynthesis, the process by which they convert sunlight into energy. This energy is the foundation of most food chains, making light indispensable for the survival of many species. Light is also crucial for our health and well-being. Sunlight exposure has been linked to improved mood and mental health, reducing the risk of depression and anxiety. Exposure to sunlight helps our bodies produce vitamin D, which is important for strong bones and a healthy immune system. Vitamin D deficiency can lead to various health issues, including osteoporosis and weakened immunity. Beyond its biological significance, light plays a vital role in art, culture, and technology. Artists have long been inspired by the interplay of light and shadow, using it to create depth and emotion in their work. It inspires artists, illuminates our cities, and enables us to communicate and explore the universe. Modern technology, from fiber optics to solar panels, relies heavily on our understanding and manipulation of light. Understanding light helps us appreciate the beauty and complexity of the natural world and our place within it. By studying light, we unlock secrets of the universe, from the behavior of particles to the vastness of space, enriching our knowledge and enhancing our lives in countless ways. Section 11, Illuminating the Future, Light's Enduring Impact. As we continue to study and explore the properties of light, we're constantly making new discoveries and developing new technologies. Scientists are working on developing faster and more efficient ways to transmit information using light. They're also exploring the potential of light-based computing. Light-based technologies have the potential to revolutionize medicine, energy, and communication. They hold the key to a brighter and more sustainable future. By understanding the fascinating journey of light, we unlock a world of possibilities and illuminate the path towards a brighter future for all.